Good morning or good afternoon. If you're watching this video, it's because you might have missed a day or two the first week back from winter break. January, I believe, like 11th through the 14th. 11, 12, 13, 14, 10 through the 14th. Or you are home awaiting for results or whatever. Whatever the reason, I hope you feel better and I hope to see you physically in school soon. But every week, since there's a surge right now and a lot of things are uncertain, I'm going to try to post one video every week, kind of like summarizing what we've done that week and then telling you the instructions of what work is going to be due in the grade book at the end of the week. So this week you guys do have an Edulastic that's due, but in order for you to do that Edulastic, you need to watch this video and you need to take notes, otherwise you're going to be lost on how to do that Edulastic. And you don't want to waste your attempts. I believe that you can check your answers up to 2 times in this week's Edulastic, or 1 time. 1 time. You can only check it 1 time. If you need more, let me know. I can try to change that setting. So that Edulastic, that's the only thing that's going to go in the grade book the first week back. I kept it light because we're all just trying to adjust to this new normal, which you guys know that it's not normal right now. So that Edulastic is going to be the first grade in the grade book. If you don't do it, that's going to be your grade in my class. So everybody automatically starts off with an A. If you don't do the Edulastic, that's a 0, so your A goes to an F because there's only one thing in the grade book. So make sure you get it done or you message me, ask for help. We're looking at book pages 253 to 272. So that's where we're at in the book. That's where I'm going to be pulling out my notes from, all the instruction, some of the questions, etc. So make sure you bring those pages when you come back to school. If you don't remember your book, you can always use it online, but this is where we're at in the book. So be ready to have those at any given moment in your folder. You can tear them out or you can bring your book Mondays, Wednesdays, and Fridays. So we reviewed solving a system of equations by graphing. And then we learned the week back solving a system of equations by elimination. So remember, when you solve a system of equations by graphing, usually you're given a picture of its graph. And let's say you have 2 lines on this graph and they intersect at this point right here. That would be considered the solution to the system of equation. This point of intersection is where x and y are true for both of the equations. So let's say that that is 1, 1. So we would say the solution to the system of equations by graphing is I'll write this. Remember, a solution on a coordinate plane is a point, and a point is written x, y. So we're going to write our solution, which is 1, 1. This means that x is 1 and y is 1. Okay? Now, if you were not given the graph, or let's say graphing is not the most reliable way or the easiest way, the most efficient way, you can also solve a system of linear equations by elimination. So this is what these notes are on. We did a Nearpod on this at the beginning of the week as a class to just kind of learn it. So I'm going to review that with you during this video. So a system of linear equations looks like this, okay? And you can solve it more easily instead of graphing. You can use the elimination method, and then we're going to learn substitution in about a week. So we can notice that we have x plus y in the first equation, and then we have 3x minus y in the second equation. Oh, equals to 5 and equals to 7. Now, if you notice, you have a positive y and you have a negative y. That means that if you were to add these 2 equations together, your y's would cancel. They would eliminate. So I want you to think back in elementary school, like when you added things together, like if you had 5 plus 7, you would just add them like a column, right? 5 plus 7 is 12. With that same idea, I want you to add this system of equations together to see if anything eliminates. And we already know just by looking at it that the y's are going to eliminate. So then we can solve for x. We can get what x is, plug it into one of those equations, and then we can solve for y, and we'll have our solution to the system of equation where they meet. So let's add this together. So we have x plus y equals 5 plus 3x minus y equals 7. So let's add them together. We have x plus 3x, which is 4x. Positive y minus y is 0. It cancels, so I don't need to write anything in its place. Bring the equal sign down. 5 plus 7 is 12. Then you just divide both sides by 4, and you get x equals 3. Perfect. You found the x coordinate of your solution. So you can already start off your system of equations, the solution to the system, the solution that's going to work for both of those. You already know that x has to be 3. Now you just have to solve for y. So you can plug in this 3 into the second equation, or you can plug in this 3 into the first equation. Choose the easier one. I think the first one is the easier one, right? So let's plug that in. So instead of x plus y equals 5, I'm going to plug in 3 plus y equals 5. And you could probably solve this mentally. 3 plus something equals 5. 3 plus 2, right? Or you can just subtract both sides by 3. 5 minus 3 is 2. So we found our x, we found our y. Therefore, our solution, where these lines are going to meet on a graph, is at 3, 2. So 3, 2, or x is equal to 3, y is equal to 2, is going to be true for both of those. So if you plug them in into both of them, you're going to get a true statement. All right, so I had to cut off that first section of the video. Now we're starting our new example. We're solving a system of linear equations by using elimination, not by graphing. All right, so if you guys look at our next example, first we have to see the system of linear equations and see if anything will cancel if we add it right off the bat. And if we add 2x plus x, that's going to be 3x. So the x's don't eliminate. And then positive y minus 3y is going to end up being negative 2y. So none of the y's cancel either. And then the constants are just going to end up being 20. So we have to manipulate one of the equations in the system so that one of the terms cancels or eliminates. So if I look at 2x and x, what do I need here to cancel out the 2x? Just think about the opposite of 2x. The opposite of 2x is negative 2x. So what I would do is I would multiply everything in the second equation by negative 2 so that I can add the equations together and something will eliminate. You can look at your x's or you can look at your y's. I could also multiply the first equation by positive 3 so that it's still its opposite. I could do that as well, but I'm going to work with the x's. So I'm going to multiply everything by negative 2, all right? So now I just distribute. Negative 2 times x is negative 2x. Negative 2 times negative 3y is positive 6y. Negative 2 times negative 3y is positive 6y. And then negative 2 times 7 is negative 14. Okay, so I changed my second equation, but do you see how I multiplied everything into that equation? So these equations are technically still equal. It's just that this one is magnified by negative 2 or reduced by negative 2. You can multiply things to equations as long as you do it consistently through to each term. Don't forget to multiply everything, not just one of them. So now my first equation is here, my second equation is here. Now I'm going to rewrite my system of equations so it's a little neater. So now I have my new system of equations, which is 2x plus y equals 13. And then my second one right here, which is negative 2x plus 6y equals negative 14. Now I'm going to add them together like I did in my first example, and I'm going to see what cancels. Well, my x's cancel. My y's, I have y plus 6y is 7y. And then 13 minus 14 is negative 1. And then I'm going to divide by 7 on both sides. And I have y equals negative 1/7. Yes, it's possible for you guys to get fractions. Do you see how if we were to graph these, it would be really hard for us to find our x because it's a fraction. It's actually negative 1/7. So that this is where graphing is not the best method to solving a system of equations. This is where elimination is the best method to solve a system of equations when you have fractions. All right, so now I'm going to use that y, and I'm going to plug it in into one of the original equations. I would say, let's plug it in into the first one. You can plug it in into the second one as well. So I have 2x plus y equals 13. I'm going to plug in negative 1/7 here. So I have 2x minus 1/7 because it's negative, so I can make it minus equals 13. Now I'm going to solve for 2x, so I have to add 1/7 to both sides. And I have 2x equals 13 plus 1/7 is 13 and 1/7. I would make that into an improper fraction. So 13 times 7 plus 1 over 7. 13 times 7, I'm going to pause the video and I'm going to just grab a calculator real quick because I don't want to do that. All right, so 13 times 7 is 91. 91 plus 1 is 92. Remember, that's all under 7. Okay, so I have 2x equals 92 over 7. Oh, that's not a good way to write it. I have to rewrite it. I'm just going to write it right here. Was it 92 over 7, guys? Yeah? Thank you. And so I have to divide both sides by 2 to get x by itself. And I don't know if you remember, but if you divide by a whole number, you can multiply by its reciprocal. So instead of dividing everything by 2, I'm going to multiply 92 over 7 like this. And then I'll have 92/14. And you can leave it like that. Typically, I want you to reduce. So I could reduce 92 divided by 2 is, I believe, 46. Yeah. And then 14 divided by 2 is 7. So 46/7, or 6 4/7. So x is 46 over 7, y is -1/7. I'm sorry that we got such a messy fraction, but basically whatever x is, that's what the system of equations is always going to be a point. So we have 46/7, comma, whatever our y was, which is -1/7. That's my x, that's my y. Now on your Edulastic, you're not going to get messy responses like that. You're going to get, most likely you're going to get like whole numbers or fractions that are less complicated than these. If you have any questions, feel free to message me or rewatch the video, or just look up Solving Systems of Linear Equations by Elimination on YouTube. There's a ton of really good resources out there. Hope everybody is okay and you have a good 3-day weekend.